Hello everyone, my name is Parag Pal and I am here with a new numerical. In this numerical I am going to teach you the tension member, that means to determine the TD, design load. Okay, to determine the design load. Okay, so this thing I am going to discuss with you how to determine these things. Okay, this topic is of the steel structure topic, which is I still use for in the steel. It comes in a steel structure. Okay, and basically for this tension member I am going to use IS code 800 2007. Okay, this is one of the IS code which I am going to use for the particular determination of the design tensile load. Okay, according to IS code 800 2007, clause number 6. Okay, at page number 32. Okay, of the IS 800 2007, there is one what can I say, the relation is to be given to that. The T is always less than TD or equals to TD. This relation, okay, or not equals, sorry, is greater than, T is always less than TD. This relation is had to be made in such a manner. At that time we can further proceed for your design. Okay, if this relation is not satisfied, if this relation T is less than TD, this relation is not satisfied, then we cannot go for a design. So in that way we have to change our section of our channel section or whatever the section you design. For that you have to change their size, you have to change their area, then and only then you can further go for, you can satisfy this relationship. Whenever this relation comes, when this relation is satisfied, then and only then you can go for further design portion. Now coming toward the main tension member, what exactly tension? We in a different language we call it as a tie member also. It also called as a tie member. Okay, and also tension member is always used for the carrying the maximum loads. Okay, and tension member, as we can see here, there are different category of the members we have right now. We have channel member, okay, which is look like okay, like this manner channel section. It is very thick actually. It is not so much of thick. Okay, it's somewhat. Okay, so such a manner channel section is to be there, I section is to be there. Okay, I section is to be there. Okay, and actually there are angle section. Okay, both angle section is to be there. Okay, so these are the different types of the angle section, channel section, I section. Maximum angle section are there, and by using this type of the angle section, this type of channel section, this type of I section, we can make one proper like lacing. We can make the column by using the four simple angle section, or by using the two channel section. We can make exactly the column section, or we can construct a different type of what a particular beam, we can particular the lacing, such a type of the thing we can construct it by using this sections. Okay, so basically where we are going to learn today what exactly the tension member, how to determine the TD. Okay, if our TD gets stressed, and what the measure we have to take. Okay, so in this today numerical, there is one numerical I have right now. Here the angle section is given to you. You have to determine the TD. Okay, by using the IS code 800 2007. This is for a limit state method of the design. LSM we call. Okay. Okay, in WSM, now still W is not exist right now. Okay, LSM is always there from 2007. It comes in IS code. Okay, and by using the 800 2007 from page number 32, there is a design strength for the we can say that for TDG, TDN and TDB for rupture, critical angle section and plate. Lots of things are given in the page number 32 and 33. We can say 32 and 33. Okay, 34 also there is some notification on 34. What is the ABC ATN also there at the topmost portion. Okay, in first paragraph. Okay, so these are the three pressures we are going to use in the. I'm not going to show you. Okay, this if you have IS code 800 2000, then just go to this page number. You can find out over there. Okay, and with the attachment with this also you need the steel book. Okay, steel book. Okay, by the help of the steel book, you can determine, you can take the all the values of the particular section. You can determine the thickness of any kind of the section. You can take the Ixx, Iyy, Cxx, Cyy, Ryy, Rxx. Okay, these things you can take only from the steel book. So you, and in examination, steel book with the IS code 800 2000 you can take in your examination. So these two things you have to place with you for the solving of such type of the numerical. Okay, without wasting more time, we further go for our numerical. So I just run it first. Okay, and I first explain you there are some different types of the some connection, but before starting this, I'll show you some connection also there. Okay, what exactly gusset plate? Okay, there is a gusset plate. Okay, in each and every numerical you find out that there is a one gusset plate which is to be over there. I just given the some marks over there. Okay, so gusset, what exactly the gusset plate? Gusset plate is nothing but if you have one wall. Okay, assume that this is your wall. Okay, this is your wall. Okay, and you have to place your any steel component on the wall. So for that you have to first place one gusset plate over there, and after that you have to attach, or whatever you have to do, you can just bolt it or weld it, any sort of the connection, any sort of section to that. Okay, so gusset plate is used for the connection. Okay, it is used for the connection between the wall panel, okay, and to the structural member. So this is what the important of the gusset plate. Now we go for the next connection. Actually there, here is gusset plate. Okay, in gusset plate, as you see here, it is a single angle section. Okay, so single angle section is to be here. Okay, which is, I just given to the ISA L1 by L2 by T. So L1 is nothing but this value, L2 is nothing but this value, thickness T is given as a thickness. So in a steel book, the same L1 by L2 is given in one column, and in next column for 6, 8, 9, 6, 8, 10 and 12. For this the thickness is given to you. Okay, you just go there and you can take the particular thickness. Okay, as per the design, this parameter can be taken into consideration. Now, it is this section what you are seeing here, it is called as a single angle section. If in examination they told you like the two single angle section placed back to back on opposite side of the gusset plate. So it is like in such a manner. If they talk about opposite side, okay. Okay, if they talk about the opposite side, then the opposite one angle section should be here, and opposite that another angle section to be there. Okay, if they told you the angle section on the same side, okay, in the angle section on the same side, so it is done in such a manner that okay. So it is in such a manner. So in that way you can just bolt it these two. Okay, or maybe it in this side, or it may be in this side, or it may be in the opposite side. Like so. So this is what exactly the steel structure is all about. Okay, so you can bolt this way. Okay, so this is what exactly used in a steel structure. So these are the different types of the connection which is come under the tension member and compression member also. Okay, so these are the basic parameters which you have to know about it. Okay, so now before proceeding for this numerical, let me tell you one thing. You have to take the IS code and steel book with you. Instead of that, you don't need any sort of the book. Okay, because I am going to take each and every topic for you. Okay, and also with me, the Deepali is also there. She is also going to take some new videos for you guys. Okay, so for that, we keep watch and keep learning my channel, and please don't forget to subscribe. Okay, so let's start with the topic number 1. In topic number 1, I have a numerical where the single angle connected to the gusset plate. So it is single angle which is connected to what gusset plate. Okay, so here we have numerical. Find the tension carrying capacity. So we exactly determine the TD. We have to determine the TG, which is called as a tension carrying capacity. Okay, of a single angle ISA. This is what single angle, and the given dimension is ISA 100 by 100 by 8. Okay, so this is what 100 is the L1. Okay, 100 is exactly the L1. 100 by 100 by T is what thickness. Okay, so along with that, if you search in your steel book, just open it and just take it out the single equal single angle, because this is L1 and L2 is a sorry, both are equal, so this is what equal angle section. Okay, so you have to find the equal angle section, and you go in next column you have to go for a thickness 8 mm. So you just you can find out that the area which is in a centimeter square, you have to convert it in an mm square. Okay, so the area you have to get, you can get from the steel book. Okay, now this is what the one given value to us. Okay, connected to the gusset plate by means of 3 bolt of 22 mm diameter. So here number of bolt is given to you all. Okay, number of bolt, that means the 3 bolts is given us. Okay, and the diameter is, that means D is 22 mm is given to us. Okay, 22 mm diameter. So we have to determine nominal diameter, which is 22 plus 2. Okay, which is come as a 24. Oh. Which is come as a 24. Okay, diameter of pitch of 80 mm center, and the pitch is given to you. Pitch equals to 80 mm center to center. Okay, this is the distance actually. Okay, by means of pitch of the 80 mm center to center in one line, Fy equals to 250, Fy equals to 250 megapascal, and Fv equals to 410. Okay. So these are what given value to us. So by using this value we are going to solve, we are going to determine the TD. Okay, so first of all I'll just clear you some concept actually. This is what the section, okay, this is what the section of the angle section, it is in such a manner. Okay, so it is in this manner, and the bolted connection is, one is here, second is here, and third is here. Okay, so in such a manner the bolted connection is given to this. Okay, so now what exactly edge distance? The edge distance, there is one formula, just write down. Okay, edge equals to, the formula is given to you is 1.5 multiplied by nominal diameter. Okay, the pitch distance formula is here is 2.5 into the given diameter. Okay, and the gusset plate distance is nothing but 0.6 into L1. Okay, so you have to write this 3 formula, which is very important for you all, because during the solving the numerical, if like here the pitch distance, that means P is given to you, instead of this, if it is not given to you, then you have to determine it from this formula. Okay, and put it in a proper calculation. Now what exactly edge distance? From the starting of the beam toward the center of the first bolt, okay, that means first bolt and last bolt. Okay, so from the starting point to the first bolt center, or the ending point to the first bolt, that means this man, only this distance. Okay, only this distance and only this distance, this two distance is called as a edge. From the edge to the center of the any bolt value, that called only as the edge distance. Okay, and the pitch distance means the intermediate, the bolts between the center to center distance of the bolt is called as the center to center distance of only bolt, that's called as the pitch. There is here two pitch distances given to you. Okay, so this is what the basic terminology of this steel structure. Okay, now they given to us I as the Indian standard angle, so it is 100 by 100 by 8. Okay, so by 100 by 100 by 8 you have to go in your steel book and determine what exactly the area which is given you in a centimeter square. So now as I already calculated, it is 15.39 centimeters square. Okay, so you have to convert it into the mm square. It is so 1539, I think wrong, yes, 1539 mm square. Okay, so this value you get while converting. So in your in your steel book you can find out the 100 by 100 by 8 is equal 15.39 centimeters square, and by this you can, I just tell you, just find out it is a single equal angle section. Okay, now you get this value. Actually the 3 bolts is assigned to you all, that they told that only the 3 bolts is to be given to you. Now remember one thing, in this numerical we have to determine the TD. We are not going to design, we have to determine the design tensile strength. Okay, they already assigned the 3 bolt with some diameter. Okay, so now this is not exactly the TD, this is not exactly the design. Okay, in design numerical only the TD is given to you all, and with respect to that you have to determine all the bolts, all the section, or you have to select some section of side. Okay, likewise, so this is what first numerical in which you have to determine exactly what the TD is to be. Okay, if you know what is the TD, then and only then you can further go for your design parameter. Okay, so in this switch, the design connection of the particular tension member or bolt compression member or column or whatever else to be there, it's only done by a bolt or welding. Okay, so these are the two only the different parameter which is used for your the design parameter. Okay, so now the 3 volts they are already given to you. So D equals to 22 mm. So what is the nominal diameter? We take the nominal diameter as a +2 value in each. If the value is given to you, that 19 mm, if the D is given, so be 19 plus 2, that is 21. We are going to add as our nominal diameter. Okay, same thing is going to done in your compression member also. Now Fy and Fu is given to us. Okay, is Fy is 250 megapascal, nothing but Newton per mm square, and Fu is 410 megapascal, that is Newton per mm square. Okay, so now as I get the area, okay, and pitch is given to us. If the pitch is not given to us, we just go for this formula. We have to determine all these 3 values. Now we coming to this value, the G. Okay, what exactly G? G is nothing but a distance in which you have to place the center of the bolt. Okay, this G is only used for the the only bolt value, not for a compression member, not for a welded connection. Okay, only for bolted connection you have to take the G. Okay, because the G is a distance where the center is defined. This center is defined. For that and only that purpose we have to determine the G. Okay, so now after this all are the basic terminologies. I am really very sorry I made this video in English because all the peoples are from a friend from the foreign countries also. They told me that Parag, I didn't understand Hindi, just put it a video in English. So that's why I placed this video in English, and my English is not so hard. It is really very simple, you can simply understand, and I just make the video in English because I wanted to improve my English too. Okay, so now here all the given parameters given to you all. With respect to that, we are going to solve the numerical and we are going to determine the TD. Okay, and then we are going to correlate the T is equals to TD. That means the T is given to us. Okay, that means we are going to determine the TD. Okay, so the TD is nothing but here not any sort of the T is given to you all. If the T is given to us, then and only then the T is the T is given to us only in the design. Okay, because in design the only this parameter from with respect to this parameter we are going to convert. We are going to compare the proper sort of the design step. Okay, so now I'll just rub it down. Okay, and after that I just solve one by one. Okay, so now first of all let me rub it. Okay. Okay, so now first of all how TD we get from page number IS code. There is a design step for the critical section and block rupture and all those things is given to you. Okay, so now main thing is that from this 3 value, that means the values are, you can find out TDG, TDN and TDB. These are the 3 values. With respect to these 3 values, you have to take the least value. Okay, what you have to take? You have to take the least value. Least value, that means the minimum value. Minimum value. Okay, you have to take the minimum value of from this 3 value, and then that value is represented as a TD. That means TD is nothing but the least value from this 3. Okay, so what is 3? All 3 are given in your IS code. You can just take it out. Okay, it's very very simple numeric. It is not so much hard. All the formulas given to you, you have to just determine the terminology what are itself invented in your these formulas. Okay, so now first of all I am going to solve this TDG. Okay, then I am going to solve this TDN and then going to solve it TDB. Now I'll brief something regarding this one. Okay, TDN solving TDN is really very simple. Just you need some formula, gross area, F and gamma MO. Okay, all these things given to you all. Okay, 2 things are given in your IS code. You have to just determine the gross area. Okay, then TDN. In TDN there is a 2 formula. You can simply find out in clause number 6.3 if I'm not wrong. Okay, also yes, 6.3. Okay, the TDN for the plate, for the block shear, plate, for rounded bar and for the bolted connections given to you all. So remember, there is a bolded connection, the beta value you have to determine. Okay, if you can determine the beta value, then and only then you can further push it for the TDN calculation. The beta value formula is also given to you. It's really very simple. You have to just determine some terminology with the help of that, like terminology like W, BS, LC and beta. Okay, W, B, LS. Okay, so these are some these things which is already given to you all in the IS code. So with respect to that, you can just determine this value, and then only then you can just put it on beta formula, and then you have to put the beta formula in TDN formula, and you get the TDN simply. Or instead of that, there is one alternate formula which is used for the check also, but the comparatively TDN formula. That means the beta formula is there, and there is an alpha formula. So beta and alpha formula, the value is not going to come in a equals. They are not, these both value not come in any sort of equal. Okay, this value always TDN always, beta value always at this stage, alpha value at this stage. Okay, as I solve the numericals. Okay, so for the alpha, there is some value given to you. Like if the 2 volts are you are using, you have to put 0.6. If you are using the 3 volt, you have to take 0.7. If you take more than 4 volt or 4 volt or welded connection, you have to take 0.8 value for alpha. Okay, so this was another also, that means that for TDN for voltage connection there is a 2 formula. Okay. Then we go for TDB. There is a TDB1 and TDB2, like 2 formulas. That means TDB is categorized as a TDB1, okay, and TDB2. So these are the 2 formulas which you have to calculate, and from the least value you have to take from this one also. Okay, so the both of the minimum, the least value, minimum, the maximum, minimum value. Okay, the least minimum value, whatever is from these 3, if actually it is from 1, 2, 3, 4, actually it is from the 4 you have to take. Okay, so now I am going to solve the TDG. Okay, so let's start. It is very simple, and I think I am going to help you all in a proper manner. So don't forget to subscribe my channel and like my video. Thank you. Okay, so let's start with this numerical. Okay, so I am going to determine the TDG. Okay, so for TDG the formula is Ag into Fy upon gamma MO. Okay, so gamma MO is value given in some table which is as a 1.1, which is a I'll place in a description box the what is a clause, what is table number for gamma MO. If I am not wrong, so the gamma MO table is given on in 25 to 30 page number. Okay, between the 25 to 30 or 31 page number, the gamma MO table is to be there, which is very simple, a simple table where the gamma MO, gamma M1 value are given. Okay, so a gross, first you have to then make the gross area. So gross area we already calculated from the steel table, which is a 1539 multiplied by 250 divided by 1.1. 1.1 value is of what gamma MO. So when we solve it, we get the value is as a 349.77 into 10 raised to power 3 Newton. Okay, so this is what exactly value we got of the TDG. Okay, now we go for solving for TDN formula. Okay, for the TDN I get the formula. My formula is alpha into net area. Okay, multiplied by Fu divided by gamma M1. Okay, so this, don't worry about the formula, all the formula given you in the steel table. Okay, so for that the alpha value is to be there. Okay, so the alpha value I already told you, if there is a 3 volt, the value is taken as 0.7. Okay, multiply by, you have to determine the net area. How the net area is calculated? You have to just see over here. Okay, net area calculated like, what is your gross area? So from the gross area to minus net diameter of the bolt minus of thickness. So it is like, what Ag you have is 1539 minus 24 into thickness is what the given to you is 8 mm. So we get the net area is like 1347 mm square. Okay, so this is what the net area you got. Okay, now so I place out the net area here. It is 1347 multiply, what is the Fu? Fu is given to you all, it is 410. Okay, I already first mentioned the Fu, and then what is the gamma M1 value? Gamma M1 value is 1.25. In link I just given you the what is the table number you have to use. Okay, don't worry about this. Okay, so why I use the 0.7? 0.7 is listed in clause number, I think is 0.3.4 or 5. Okay, so in there is a for 3 bolt. Okay, for 3 bolt it is listed 0.7. Instead of the 4 bolts is applicable over here, then and only then you can use the 0.8 instead of 0.7. If in case of there is no any bolted connection, if there is a welded connection, then you can go for the 0.8 also, because for welded connection 0.8 is only applicable. Okay, so now you get the, after solving this value, I just get one value which is the calculator 309.27 into 10 raised to power 10 raised to power 3 Newton. Okay, this is what one this formula is called as an approximate formula. Okay, in examination you cannot go for a long formula, because this formula takes a lots of time, and only because of that you are not liable to complete your numerical within some given time. Okay, as the 4 hours is given to you all, but instead of 4 hours you cannot solve this numerically in normal manner. Okay, so there is also the different main formula for a TDN is the TDN equals to, okay, the formula is like is 0.9, okay, 0.9 ANC into FU, okay, upon gamma M1 plus beta into AGO, okay, multiplied by Fy divided by gamma MB. Okay, so this is what the relation exactly. For that you have to determine this beta, and the beta formula is beta equals to, okay, the formula is 1.4 minus 0.076 WFY BS, okay, divided by thickness multiplied by FU multiplied by LC. Okay, so this formula is given to you all, but the relation which is you have to satisfy is that this value is less than equals to 0.9. This is not you can just take and divide it. Okay, this is a beta connection, beta formula, and but this value is less than always 0.9 FU. Okay, let me draw properly. 0.9 FU into gamma MO divided by Fy into gamma M1, Fy into gamma M1. Okay, so it is like this relation when satisfied, then and only then you can take the value of beta. So that's why I just suggest you, instead of going this long formula, just first write down this formula TDN, then the beta formula is over there. You have to satisfy this condition, then and only then you can place the value of the beta out there. So instead of that, you just go for this simple formula, place the alpha value with a proper manner. The clause is given to you all. In the clause, the particular which alpha value you have to take for number of bolts is given there. So you have to just take the proper alpha value and just solve in a simple manner. Don't take this difficult way. Okay, but in software, this formula and this for both formula is applicable. Okay, so according to IS code, these both two formula are liable to solve the TDN. Okay, now in next step, that is we have to determine the TDB. Okay, so it is in such a manner. I just rub it. Okay, you just write down whatever I write down, because my whiteboard is not so much sufficient to write down all the numerical. Okay, so that's why I takes too much time to rub it and then just write down. And actually I don't have the camera also print, so I just do with my some laptop camera. Okay, so just sit down. Just mind it, don't mind it. Okay, so now we are going for the next calculation. As I already told you, the TDB. Okay, the TDB, this is we have to determine TDB1 and TDB2. Okay, so for TDB and TDB2, I just take it in the next my lecture. This is my part 1. Okay, so I hope that you just subscribe my channel, just like my video, and this is what part 2. In next part 2, I just brief what exactly TDB and TDB2, and I determine and I just show you what is exactly the value of TD. So hope you like my video. Keep watching, keep learning. Bye bye.